The history of the atom. Atoms are one of the most complex ideas ever invented in the history of science. The idea has a very long history, a history which is still being made today. This video lecture summarizes this history, starting in 400 BCE with the Greeks, skipping the Dark Ages until the 1700s, where scientists brought back this old idea of atoms, examining how these ideas were developed in the 1800s, and then lastly looking at modern models of atoms as they pertain to biology class. The word atomos means indivisible in Greek, and the term was coined by Democritus. Legend has it that this ancient Greek philosopher was sitting in the foyer of his house while his servant was baking bread in the kitchen, and he took a deep breath in and... oh, how delicious is that bread. Wait a minute. How am I smelling that bread? The bread is in the kitchen and I'm in the foyer. That must mean that there are small pieces of the bread that are floating through the air from the kitchen, through all the rooms in my house, to the foyer, and then up into my nose for me to detect them. What shall I call these small pieces of bread? I'll call them atoms. Small, indivisible pieces of bread. It was such a logical idea that many other Greek philosophers really liked it, such as this guy named Plato. Amongst other things, Plato really liked shapes. And he believed very strongly in our powers of imagination. So if we could picture something in our minds, then that might make it true. And he used his mathematics to imagine what atoms might actually look like. For example, he thought that fire might have a very sharply shaped atom that would cause it to burn you when it touched you, or that an atom of earth would be shaped perfectly for building things such as bricks and houses. I think it's a kind of clever idea, but even back in those days, students were unruly. This guy was Plato's student. His name was Aristotle. He took one look at his teacher's creative ideas and said, "Where the heck are you getting that from? Yes, you can think it up in your mind. Yes, it works mathematically. But what physical evidence from the world, from your senses, do you have to suggest that fire is actually made out of triangularly shaped atoms? No way do atoms exist, and no way do they have these crazy shapes." Aristotle was one of the first real scientists because he said, you can't just think up an idea and then it's true. In science, you have to be able to detect that truth by sensory input before you believe it. For this reason, he rejected the idea of atoms existing, because there's no way to sense atoms, or there was no way in his day and age. And so he says, all right, enough with that atoms crap. Let's get an idea that we can actually feel. I think all materials in the world are made out of 4 elements. Fire, which is hot and dry, earth, which is cold and dry, water, which is cold and wet, and air, which is hot and wet. To make any other substance in the entire universe, all you have to do is combine the right amounts of each of these 4 elements, and voila, you have your substance. He even used his idea to explain gravity long before the idea of gravity existed. His version of the idea was called natural motion. That is, all elements will move until they assume their natural position in the universe. So Earth had a natural motion to exist only in the middle of the universe. And its natural motion was even stronger than that of water. So if you threw a stone into a lake, because of its natural motion, his explanation was the stone would drop right to the bottom of the lake until it hit the earth, until it achieved its natural position. Air was next, which explained why, if for some reason there was a little air bubble that made its way underwater, that it would move upward until it rejoined the air. Fire was last, which to Aristotle explained why a flame always reaches upward towards the sky. A pretty creative idea for someone who had no idea what the term air density meant. So even though his scientific ideas were complete, he was at least the origin of a basic tenet of science, that your explanations should come from observation. His theory of natural motion explains the way this candle looks on Earth pretty well, with the flame reaching upward. Perhaps if Aristotle could have traveled into space to see what the flame looks like there, and he noticed the round shape of this flame that no longer reaches upward, then he might have changed his opinion. It was almost 2,000 years before Aristotle's ideas, which were promulgated by the Catholic Church, were finally overturned. This scientific revolution was instigated by the discoveries of two French chemists, Monsieur et Madame Lavoisier. At that time, and even today, most people assumed that when an object rusts, it is breaking down. In other words, it is losing mass. But the Lavoisier were the first to challenge that assumption and actually weighed objects when they rust, finding that the rusted object is indeed heavier. This finding completely baffled them and other scientists of the time. Some scientists assumed, sort of like with spontaneous generation, that the rust must be coming out of nowhere, and that the matter, the material of the rust, was being created as the metal rusted. But the Lavoisier had a different idea, and thus set up a slightly different experiment. What would happen if they let an object rust in a closed container? To the surprise of many, the object that rusted in a closed container, including the air around that object, weighed the same both before and after the rusting had occurred. From these results, the Lavoisier developed their law of conservation of mass, which states that mass can neither be created nor destroyed. That rusting object wasn't getting matter out of nowhere, it was actually extracting matter from the air. And if matter couldn't come out of nowhere, that must mean that air, the stuff that got trapped inside the bottle, must be made of matter. That was a difficult pill to swallow back then. It's even a difficult pill to swallow right now, because if you look at the air right in front of your face, it's totally clear. Anyone with a healthy sense of skepticism has to wonder, really? Is air really made of something? It was at this point that an English scientist named John Dalton thought, maybe air is made of atoms.
I'm bringing atoms back, yeah. They are small particles that can react, yeah. In set proportions and whole numbers that, yeah. Show elements have their own atoms whack. Take it from the Greeks.
So thank God John Dalton studied really old, dead Greek guys, or else he might not have had this idea. But in observing the chemistry that was being performed by scientists of his time, he thought that this idea of atoms, these small indivisible particles that make up all of matter, was a very useful explanatory tool. As he and other scientists started separating and sorting out different materials, they started to realize that these different materials were made of different atoms. Some substances even seemed to be combinations of different kinds of atoms that they called compounds. And to make these compounds required the mixing of exact whole number ratios of different types of atoms. These set proportions and whole numbers demonstrated to Dalton that there was no such thing as half an oxygen atom or half a hydrogen atom. Matter came in discrete individual particles that could not be divided. And each element had its own special particle associated with it. The ancient Greek idea was resurrected.